Hello ladies and gentlemen, Easy Ellie here, and today we're gonna be talking about voltage dividers. Yes, even though they're very simple in nature, they are used in many applications, such as sensing a voltage or generating the reference signal and many more. So yeah, let's get started. So let's assume I've got a 10 volt system or generator or power supply or whatever, or signal, whatever you want to call it, and you want to convert it down to 5 volts. So how can you do that? So imagine my system is here, which is just a power supply 10 volt. Then this 10 volt will go through some circuitry where we call it voltage divider, which gives the 5 volt output. So if I go inside this block here, I'll see that the voltage divider is really nothing but just two resistors. And if you get the output from between the two resistors out, that will give you a certain amount of voltage which can be calculated using this equation. So you can really manipulate the value of resistors R1 and R2 to get whatever voltage that you want at the output. However, be reminded that this system can only be used to step down the voltage or reduce the voltage, and it can really not be used to increase the voltage. So whatever you're supplying to the system, let's say it's 10 volt, you can only go below 10 volt. You cannot go higher than 10 volt. There are some certain circuit topologies that can do that, which I'll be discussing them in the next videos in the future. So let's say I'm having a resistor R1 here equal to 5 ohm. Let me set it to equal to 5, and I set resistor R2 to 5 ohm as well. Now, if I use this equation, I have 10 volt signal being applied to them, so it's going to be 10 multiplied by R2, which is this one, which is 5, over 5 plus 5. So in the output, I'm supposed to get 5 volts from this equation. So if I run the simulation and go back, I will see that I'm getting 5 volt. Perfect. So what is the problem with this circuit? Yes, this is very simple, and we just turned 10 volt to 5 volt. But there's many limitations which we have to know about them. The first important problem is that if you use low value of resistors here, your system is going to be so inefficient, and you're going to have so much thermal problems in the system. Why is that? Let's see. So let's see how much current is currently flowing through our system. So if I call this current I, my current I from simple Ohm's law is going to be 10 divided by R1 plus R2. So it's going to be 10 divided by 5 plus 5. It's going to be 1 amp of current, right? Now, we know that the amount of power loss in a resistor is going to be Ri squared. So if my resistor is just equal to 5 ohm, then I'm going to lose 5 times 1 squared, 5 watt. So I'm going to lose 5 watt of power simply in resistor R1 and another 5 watt in resistor R2, which gives me total loss of 10 watt. 10 watt is ridiculous amount simply because this circuit is just meant to step down the voltage, and you're already losing 10 watt of power for nothing. So this is really inefficient, and the problem is that if you want to generate, if this amount of power loss is going to cause so much thermal issues, and generally this results in usage of very big physical size of resistors. Usually the small resistor size are in range of 2 watt power. You cannot really go beyond that, or they will just burn out. So how you can fix the issue? Well, one of the simple solution is to simply increase the value of resistors R1 and R2, right? Because this is the ratio, so even if we increase the values, we still can get whatever voltage that we want at the output. So let's say I set resistor R1 to 5 kilo ohm. So if I type 5 times 10 to the 3, so R1 10 to the 5 kilo ohm, and R2 same, 5 times 10 to the 3. So if I use this equation, I will simply and do the calculations. You will see that this gives again 5 volts. So if I run the simulation again and go back here to the scope, I will see that I'm still reading 5 volt signal, right? So perfect, it's working now. Now if I calculate the power loss now, my current, so first I need to calculate current, right? So I have 10 divided by 5 plus 5 times 10 to the 3. So now I have only 1 milliamp of current flowing through my system. Now if I calculate power loss now, power is equal to RIS squared again, just to remind you guys. So it's going to be 5 times 10 to the 3. Let's say I'm using resistor R1 times 1 milli squared. Now 1 milli squared is going to be 1 micro, and if you multiply by 10 to the 3, it's simply going to be 5 milliwatt, right? So I went, and so this is just through one resistor's R1, right? So if in total you will lose 10 milliwatt. So I went down from 10 watt to 10 milliwatt, which is huge. It is 1,000 times less amount of power loss as compared to before, which means in this case we can actually manage the thermal issues in this case, and you can also reduce this further down if you use this resistor in range of mega ohms, right? However, the problem is that if you use higher value of resistors, the amount of output current that you're getting out of your voltage divider here is going to be limited, right? Because imagine this is a water flowing through this stream, and then you're using a big blocks here. This big block is gonna avoid flow of current. So the bigger you use this block, the less current the less water you will have flow through here. So if you increase this resistor here, sorry, let me just erase all this. Yeah. So if you use this too much big of a resistance here, this is really gonna limit your current going through because this is the path of current, right? So if you use big resistor here, this is gonna really limit the amount of output current that you get through here. So this is really one of the main disadvantages of this circuit. So you cannot really use this topology if you want to use it in high power application systems. There are other topologies you can use, which I will be discussing in the future videos. But for this case, you can only use this circuit if the amount of output current you're getting from here is less than the amount limited by this resistor R1. Another problem that this circuit has is mismatch resistance. So sometimes you will see that even though you only intend to get low amount of current from the output of voltage divider, the amount of voltage that you will see here is not what you desired, even though you designed the system based on this equation. Now in that case, there is a resistor mismatch in your system, which is easily solvable, which I'll be discussing it in my next video, which will be coming out soon. Hopefully you guys enjoyed this video, and if you found it helpful, please don't forget to like and subscribe. Thank you.